Hi guys, welcome to the first video on the Nuclear Physics Unit, Chapter 7.1, where we'll be looking at discrete energy and radioactivity. Today the learning objectives will be some basic definitions of the continuous spectra, emission spectra, and absorption spectra, and also the word discrete. A follow-up video will be made on using diagrams and making calculations. So first off, what the word discrete means is we're looking at things that are of a unique or a distinct color. So we usually see the word discrete being used to talk about a single color of light that's being emitted. And I really encourage you guys to look at the videos at the beginning of Cognity that look at neon light signs. So with neon light signs, this is actually kind of interesting, especially because we live in Hong Kong. So we've got quite a few neon light signs. So neon light signs are produced using an electrical current or a voltage. So a voltage, sometimes called a potential difference. Or sometimes they might talk about current flowing through it, which is just electricity. So you might see both of these words refer to what we generally call electricity, which we'll study next in our last unit for grade 11. So what neon signs are is that there is a little tube inside, and there's little gas particles. And when we run electricity through that, we get a single color of light that shows up in whatever shape that it takes on. So this actually has a lot to do with what we'll be talking about coming up next. So um, that's actually an example of an emission spectra where you need a hot gas. So electricity is applied to make the gas hot. And when it's hot, it will produce an emission spectra, which is just a line spectrum in which discrete light lines are set against dark background. So really what that's saying is that a single color of light, a discrete light, a single color of light is being emitted as a result of that. Continuous spectra is what we normally call white light, okay, or light from the sun. So light from the sun can be split using a prism. So continuous spectrum. So we can have a prism, right? Light can come in from the sun, and then it gets split into all the different colors. And we just talked about emission spectra, which is using a hot gas, usually applied by electricity. It gives us the heat. Electricity gives us the heat. And then we have an absorption spectrum in which cold gas can also be applied. So cold gas will allow us to absorb or take away light. And I guess the other thing to also think about is something that is cold. Actually, we haven't talked about this in the thermodynamics unit yet. But the idea is that when something's cold, it lacks energy. So the idea that cold, lacking energy, taking light away, that actually makes a lot more sense. This is a nice little table that I thought about, and it just helps organize the information a little bit. So continuous spectra, we're going straight down here. So continuous spectrum produces all light, doesn't require any temperature filters, so no filters necessary. And as I already mentioned, all the colors are available. An absorption spectra produces most of the lights, where a few of them are absorbed. And this is where we have cold in terms of our temperature. And some of the colors are blocked or absorbed, so absorption spectrum. Emission spectrum. So this is our neon lights, where few lights are given off, so we only want one single color of light. Hot gas, usually done by applying electricity, and we have a few colors against a dark background. So when it's dark outside, those colors will show up. And do pay attention to this diagram in Cognity. We've explained most of it already, but the idea of the hot light bulb, that's sort of the source of the light has to be, that's essentially saying it's white light that's coming out, okay? And it could be split, it could be absorbed, or by applying hot gas, we only get a certain type of color coming out from that. Okay, so this doesn't actually really require white light so much as it requires a gas that is hot, and it's going to give off light on its own. Okay, thank you for watching, guys. We'll see you in the follow-up video.